Okay, so in this video we are going to be looking at two concepts called the angle of elevation and the angle of depression. So these are sort of applied problems, and we use this in trigonometry for lots of things, but for this class we're just going to be using this for word problems and some applied type topics. So first off, what is the angle of elevation? Well, the angle of elevation is the angle that we're looking up. So imagine I'm standing here at this log cabin and I'm looking straight across. So this horizon, this is eye level. Now, if I take my head and look up, I'm looking at some angle above the horizon. I call that, direction that I'm looking, that's my line of sight. Now, if I were to take a line straight down and make it perpendicular to the horizon, notice I have this right triangle in there. And this is what we call the angle of elevation. So this angle between the horizon and my line of sight. The angle of depression works the same way, except we're going downwards. So depression, means down. So imagine I'm sitting at the top of this lighthouse, horizontally from the top of my head, from my eyes, this is the horizon. And then now, instead of looking up, I'm going to look down or try to follow this. So I'm going to look, let's do that same color blue. I'm going to look straight down now at this buoy. And so notice that the angle in here formed between my horizon and my line of sight, that's my angle of depression. So angle of depression is just formed by looking down. Angle of elevation is formed by looking up. So let's look at some examples here. So here we have a staircase with an angle of elevation of 28 degrees, which covers a horizontal distance of 17 feet. What is the horizontal length associated with the staircase? So a lot going on in this problem. So first off, we have that this angle of elevation is 28 degrees, and that is the angle between the horizon. So here's the horizon, and between the staircase. Now here it's telling us that the staircase covers 17 feet. So this distance is 17 feet. So it wants to find out what the horizontal distance is. Well, remember, if I take this distance and I drop it straight down, this is the hypotenuse. So it's going to be longer than that horizontal distance. So it's asking for this value x, and the picture makes that clear. Well, we've looked at our trig functions before. So notice I have the hypotenuse. This is my adjacent side. So which trig function deals with the adjacent side and the hypotenuse? The adjacent side and the hypotenuse. Well, that's the cosine. Cosine of theta is equal to adjacent over hypotenuse. So in this case, I know that the cosine of 28 degrees is equal to the adjacent side, which in this case is x, over my hypotenuse is 17. So if I want to get x by itself, I just multiply both sides by 17. So I get 17 cosine of 28 degrees. Now, I know a lot of you guys like decimals and using your calculators, so you are in for a treat because we are going to be using our calculators to solve this. So your calculator has buttons for sine, cosine, and tangent. What we first want to do is we want to make sure that we're measuring in degrees. So we have to go to mode, and you'll notice that this one option here has radian and degree. We want to make sure that we go over to degree and hit enter. Radian is something else. You will examine that in algebra in pre-calculus. For us, we are just dealing with degrees. And You can always tell because this has a degree symbol. So we're going to quit out of this, and we're just going to type in exactly this. So we are going to get 17 cosine of 28, and because I told the calculator this is in degree mode, it's going to calculate this in degrees. And so there we go, I can round this off to 15.01. So that means that this is going to be 15.01 feet. And that's my answer. So we want to set these up as trig equations. Here we have an example of an angle of depression. So here's this angle of depression. Now the cool thing about angles of depression are they're formed from the horizon here. Well, if I'm making this triangle, notice I've got this. Well, if this distance is 3.5 feet, remember, that's a vertical distance, so I can drag that all the way down here, and so this is now my triangle. So this is the same as 3.5. So it says this tailgate of a van is 3.5 feet. That's my vertical distance above the ground. The loading ramp, which in this case is a hypotenuse, has this angle of depression of 10 degrees. We want to find the length of the ramp. So that's the hypotenuse. We want to find the length of the ramp. Well, that in this case would be the hypotenuse. And if this is my reference angle, I have the opposite side. So this is the sine. Sine of theta is opposite over hypotenuse. So I have the sine of 10 degrees is going to be equal to the opposite side, which is 3.5 over x. So a little bit of algebra here, but remember we can switch this whole value and this denominator. So we get x is equal to 3.5 over the sine of 10 degrees. Going back to our calculator, we're already in degree mode, so we don't need to switch that again. So we can do 3.5 divided by sine of 10. Make sure I close all my parentheses. And there we go. So 20.16 we'll call it. So this is 20.16 feet. That's my answer. So setting up the trig function, plugging in the values we know. We have the three trig functions, sine, cosine, tangent. Make sure you choose the appropriate one. For example, if I chose cosine here, it wouldn't help because I don't know the adjacent side or the hypotenuse. If I chose tangent, I'd be able to find the adjacent side, but I'm not looking for the adjacent side. I'm looking for the hypotenuse. So make sure you get the correct values there. All right, here are two more examples we can take a look at. So 50 feet from the screen of a drive-in movie. So that is this distance here. If this is my reference angle this is angle of elevation. I have the adjacent side. And in this case, I'm looking for how tall is the screen. So how tall is it? Well, that's my opposite side. So in this case, I'm looking for the tangent because tangent is opposite over adjacent. So the tangent of this 58-degree angle is equal to the opposite side over 50. So that means that that opposite side, which we'll call x, is equal to 50 times the tangent of 58 degrees. All right, so going back to our calculator, we get 50 times the tangent of 58. And so there we go, 80.02. So 80.02 feet. That's how tall that giant movie screen is. Right, next up, we have an angle of depression. So we can see that the angle of depression going downwards is 40 degrees from the horizon. We have that this distance from the boat directly to the ship is 500 meters, but that is our hypotenuse. We want to find out this. We want to find out how deep is the sub below the surface of the water. That is, in this case, this is the opposite side. So yet again, we have another sine function because the sine of theta is equal opposite over hypotenuse. So the sine of 40 degrees is equal to the opposite side over the hypotenuse. So we get that depth, x, is equal to 500 times the sine of 40 degrees. All right, so we get 500 times the sine of 40. And so we get 321.39. So x is equal to 321.39. In this case, meters. Here's some more questions. So setting these up kind of works out the same way. So at 2 p.m., the shadow of a lighthouse is 19 feet. The angle of elevation is 75. So we want to find out how high this is. So the height, I'm going to call this x so I don't confuse anybody with, h for hypotenuse. Because we know in this case, if we have the adjacent side and we're looking for the opposite side and the adjacent side, that's tangent. So we get that the tangent of 75 degrees is equal to the opposite side x over the adjacent side. So we get that x is equal to 19 times the tangent of 75. Plugging this in the calculator, we get 19 times the tangent of 75. Is equal to 70.91. So we get that x is equal to 70.91 feet. All right, next up we have bleachers for a concert. So the angle of depression is 24 degrees. And so the seat is 45 feet high. We want to find the distance to the actual stage. So if I'm sitting right here and the stage is right there, if I just drew a straight line to the stage, how far away would I be? Well, if I'm looking for the hypotenuse, and I have, in this case, so it might help if I do this and say this is 45 feet. That makes it the opposite side. So that is a sine function, so sine. So I get the sine of 24 is equal to the opposite side, which is 45, over the hypotenuse, which is, in this case, is d. So d is equal to 45 over the sine of 24. Okay, and so we do 45 divided by the sine of 24, which is 110.64. So this is equal to 110.64 feet. And that is our answer. And finally, we have this airplane landing coming in. The angle of elevation in this case is 3. This distance here is 500 feet, and we want to find what point will it be touchdown. So that, yet again, is another hypotenuse, and this time we have, yet again, the opposite side. So this is another sine. Sine of theta equals opposite over hypotenuse. So the sine of 3 is equal to the opposite side of 500 over the hypotenuse of d. So we get that d is equal to 500 over the sine of 3. So if we actually plug that in, we get 500 divided by the sine of 3. Okay, so that's 9553.66. So distance is equal to 9,553.66. This is feet. So we got 9,500 more feet to go till touchdown. Okay, so these problems aren't that bad, especially if we're looking at a picture. Just make sure to draw the right triangle and your trig function, either sine, cosine, or tangent.